Okay, we're on the hour. My name is Horst Simon. I'm the director of ADIA Lab, and it's my great pleasure to welcome you to the fifth presentation in our best paper competition for data in climate. And I'm just going to introduce the speaker and then make sure that all the speakers have exactly 30 minutes time. So today we're welcoming Zacharias Sautner from the University of Zurich, and he will present about firm-level climate exchange exposure. Welcome, Zacharias.
Thank you very much. First of all, a big thank you to ADIA Lab and the jury for shortlisting our paper. It's a great honor and also a great opportunity to present the paper to a broader audience. I'm located in Zurich, and my co-authors are also in the call, and I'm very glad about this. These are Lawrence van Lent, Greg Wilkoff, and Ruishen Zheng, and they're in Frankfurt and Hong Kong. And
Good.
what we do in this paper, to say it in one sentence, is we create a firm level quarterly measure of how exposed companies are to climate change. And we show this is a useful measure, it's a valid measure, and we were glad and happy that our paper was not just published recently in the Journal of Finance, which is widely perceived as the top academic journal in finance, but also that it was recently ranked as the most cited paper actually published in the Journal of Finance in the last 5 years. We have decided to split the talk in 3 components, having in mind also that it's a bit of a broader audience here in the call. First, we're going to talk about the paper's context, the role of finance for climate change. Then we talk about the paper's approach to how we measure firm level exposure to climate change. We talk about measurement specifics, about validation, that it's a valid measure, that's a good measure, and of course also about applications, that it's not just a good measure, but also a useful measure. And then we're going to talk a little bit about the paper's impact and the so what question. Finance plays a major role in the fight against climate change. The reason is that the green transition that we all hope to contribute to requires huge financial resources. There are estimates that indicate that between 100 trillion, not billion, 100 trillion and 300 trillion are needed until 2050 in order to successfully make the green transition and, for example, be consistent with the plans of the Paris Agreement. Now, if you think about finance, and we're all finance professors and accounting professors, what you need is, to achieve these goals, you need to reallocate capital in the economy. You need to reallocate resources away from the brown firms towards the green firms. But more than that, also for those brown firms that find it very hard to transition because of their business models, you need to provide financing so that they can become cleaner in what they're doing. And in fact, there is a clear imperative, if you read the Paris Agreement, for the financial sector. It says in Article 2C, and that's the key article in 2A, it defines the 1.5 degree and the 2 degree target. Already in that article, it says that we have to make finance flows consistent with a pathway towards low emissions and climate resilient development. So it's a clear imperative that to achieve the 1.5 degree target, there is a role for finance, for the financial sector to achieve this. To put it differently, if we fail with a 1.5 degree target, it's in parts also the fault of the financial sector. Now, what that means is that not just is finance part of the problem, because the emissions we have been observing over the years, they were financed by debt and equity, by capital markets, but also that finance has to be and can be part of the solution. Now, in order to be part of the solution, you have to tackle a big challenge, and that's a lack of firm-level, high-quality measures that indicate where capital needs to flow to and where it should move away from. You need capital flows to be adjusted based on informative signals about firm-level exposures to climate-related risks and opportunities. Only if you have these measures available, investors can shift the capital flows. Without these informative measures, it's very hard to understand where money should move away and towards to. Now, for these measures to be useful, they need to be timely. That is, not just historic, but frequently updated. They need to be available at scale. Large investors, as ADIA knows, and others as well, invest in thousands of stocks across the globe. So they need to be the measures available for a large portfolio of firms. They need to be transparent so that others can challenge the measures. They need to be neutral. And as we all know, this has become a big issue these days, with sustainable finance being strongly politicized. And it needs to be open source. And that there is a great challenge is illustrated by two quotes that I would like to give to you. One from a practitioner, one from a set of researchers. I'm quoting the UNEP Finance Initiative. They say, where climate data is essential, significant gaps in data critically undermine the robustness of related risk analysis and could compromise the efficiency of relevant decision-making. Giulio, Kelly, and Ströbel, two of the world's leading scholars on climate finance, they say there is substantial scope for improvements of the measures of climate risk exposure, in particular for equity assets. Now, what do we do to address this challenge? Our paper develops and makes available exactly the type of data that seems to be required based on the quotes that I gave you. What we do is we introduce a method that identifies firm-level climate change exposure, and we identify that exposure from earnings conference calls. What are earnings conference calls? On a quarterly basis, companies have calls in which management presents current earnings and gives insights into the future expected financial performance. And in these calls, there are financial analysts that are challenging, probing the presentations of management in a Q&A session. So what we do in order to measure climate change exposure, and that's a key assumption, is we say we're able to measure exposure based on the attention paid by managers and financial analysts to climate topics. So our measure is based on earnings calls and the extent to which managers and financial analysts discuss climate topics in these earnings calls. Now, what's a big strength of our measure is that we're able to capture multiple dimensions of exposure. We're able to capture from the earnings calls exposures to opportunities, when managers and analysts talk mostly about the chances, the prospects that firms have with respect to climate change. But we are also able to measure exposure to physical risks, sea level rise risk, extreme weather, as well as to regulatory risks, transition risks, for example, stemming from a carbon tax or other related regulation. As indicated, our measure provides a large coverage. It's frequently updated as we speak on a quarterly basis. We haven't stopped with the paper. And you can go back in time until 2002 to measure firm-level climate change exposure for more than 10,000 firms now across 34 countries in the world. Importantly, our measure is transparent. The code is publicly available at the Journal of Finance webpage, and we have made the data available publicly for other research teams to use them. And I'll show you in a moment, there are dozens of papers since our paper was published that have been using our data. And let me emphasize the transparency aspect. There are other measures, like commercial data providers, for example, that also provide indications of climate change exposure using very different approaches. However, a big concern voiced by regulators and investors is that these measures are not transparent. They are black boxes. And that can lead to very complicated, potentially systemic issues. Suppose some of these intransparent measures are wrong and no one was able to challenge them. Now, let me speak about the method that we're using. In line with your call for papers, our method addresses the climate data challenge with data science. I already said we identified a proportion of a conference call, of an earnings call, that discusses climate change topics. And so intuitively, what we do is we capture the time that management and analysts spend on the topic of climate change and use this as a measure of a firm's exposure to climate change. Now, where's the data science aspect? In order to measure whether in the transcripts of these earnings calls, companies talk about climate change, you have a set of choices to make. For example, you can use an approach where you have a pre-specified training library that you use in order to identify whether these calls, these managers and analysts talk about climate change. Now, we try to do this. It's a simple approach, but unfortunately it doesn't work. The reason is that if you take a pre-specified training library, like, for example, IPCC reports or similar, the language is very different from the language used by financial analysts and managers in earnings calls. Climate change experts tend to use a very different vocabulary. So you cannot use a pre-specified training library and then apply that to earnings calls. Now, what's the data science solution? And that's a novelty, we apply a keyword searching algorithm to identify climate change bigrams. And it's a very transparent approach. The only key item you need is you need to define a set of initial bigrams that are unambiguously about climate change. And the algorithm then searches, and I'll explain on the next slide the details, other bigrams, so two-word combinations, that are also about climate change because they are used in a similar context. And so you expand from an initial set of clear bigrams related to climate change to a broader set of climate change bigrams because this broader set is used in similar contexts. So our machine learning algorithm, one that we apply here in this context, consists of 3 steps. Step 1, as indicated, as an input, you need an initial set of climate change bigrams, 50 in our case. And for those, very transparent, it's very clear that they're about climate change. Examples are, out of the list of 50, climate change, renewable energy, or carbon tax. Step 2 is then, we train a machine learning model to predict if a sentence from an earnings call is about climate change. So the intuition is the algorithm searches for new bigrams beyond the initial list that are discussed in the context, in the proximity of the initial bigrams. And it's very hard to identify these other bigrams based on any pre-specified list of bigrams. For example, it may be that in the context of the word carbon tax, analysts ask about a specific renewable energy project with a very specific name. It's impossible to identify in a pre-trained library such a name of a renewable energy plant. But you're able to identify it from the context of the earnings calls. We then do this in a training set and apply then the prediction model to sentences that do not include the initial bigrams. And we're happy to dive deep into the specifics algorithm if you have questions later in the Q&A. Now, the beauty of the approach is we can adapt the algorithm to find climate change bigrams that are capturing different climate change topics. Opportunities, regulatory risks, physical risks. All you need to do is change the initial set of bigrams. So in what you will see is we have a measure of overall climate change exposure that includes both upsides and downsides, opportunities and risks. And we have more narrow measures of exposure that focus specifically on opportunities or physical and regulatory risks. And for these subtopics, so to speak, all that is different is the initial set of climate change bigrams. Now, this is the key formula capturing how we measure overall climate change exposure. And it's intuitive. You see here, climate change exposure of firm I in quarter T is essentially the sum of those bigrams that are featuring in an earnings call transcript that are part of the discovered climate change bigram set. And the discovered climate change bigram set consists of these initial bigrams as well as those that are newly discovered through the keyword searching algorithm. So it's the fraction of the call that is about climate change topics. And as you can see here, you can replace the set C when constructing topic-based measures by simply using a different set of climate change bigrams. Now, in order to make sure that our approach is sensible, we conduct a series of validation exercises. First, and importantly, to make sure this is not just a black box, we consider the face validity of the climate change bigrams. We look over those that are discovered, that are most frequently used, and see whether they make sense. Second, we perform structured human audits in which 2,000 text fragments were coded by us as well as students that we have recruited. Third, we show that our measures are very robust. For example, they are robust to excluding one keyword at a time from the initial bigram list. And fourth, we also find that this keyword search-based measures substantially improve the identification of climate change discussants relative to alternatives that are using keywords only. So the simple approach. So you get a lot of extra mileage through the keyword searching algorithm. For example, if you look at the firms in the top 10% of climate change exposure as identified by our algorithm, you would identify only 27% of those if you would be using an approach using the initial keywords only. Then at the transcript level, at the firm level, we also do a lot of validation to make sense of the measures. Here too, you can see on the left a ranking of those sectors that are in the top 10 based on the firms in the sector climate change exposure. The top 3 sectors are electric, gas, and sanitary services. So these are utilities. 6.95 means that out of 1,000 bigrams, 7 bigrams on average are related to climate change, but with a big standard deviation. The second most highly ranked sector is heavy construction, except building, and that's followed by construction, and then later transportation equipment. Now that's for the overall measure. Okay, so it incorporates overall exposure, capturing both opportunities and risks. And of course, we also look carefully at the sub-measures, what kind of firms have higher exposure to regulatory and physical risk and what industries, and also all of that makes a lot of sense. On the right side, you see over time, over the years for which we have used the measure in the paper, how climate change exposure changed over time. And you not just see that there is a general increase in attention based on the earnings calls to climate change topics, but it's also varying quite a bit over time. Now, as further validations, we look at the correlation of the measure, especially also the regulatory exposure measure, with carbon emissions, for example. We find strong correlations, and of course also make sure that everything we find is not just capturing carbon emissions. And we show that it varies also over time, our measure of exposure, with climate change attention in the public as captured, for example, based on indices that look at news discussions on climate change, as at newspaper articles talking about climate change topics. Now, the validation is about whether the measure makes sense. What we also do is we show the measure or the measures are useful. You can use firm-level climate change exposure to predict real outcomes that are critical for the green transformation. And when I mean predict, I really mean outcomes ahead of the time where you measure climate change exposure. And that's a strength over other measures like emissions that are backward-looking, because earnings calls discuss, I mentioned this, forward-looking expected events, expected developments of companies, and are therefore having a forward-looking feature in how they're constructed. So we show that the measures offer insights that contribute to our understanding and mitigation of climate change. Again, very much aligned with your call for papers. We show the measures predict real outcomes that are critical for the green transition. Let me be concrete. We look, for example, at green tech job creation. Something also, as you know, very critical for the region where you're located, as well as green patenting. And you see one example out of many that we have in the paper where we run regressions linking green patents to our exposure measures. And we control for all kinds of other variables that may affect green innovation. And you see, for example, that firms that have a higher exposure to climate-related opportunities, as captured based on these discussions in the earnings calls, they are more innovative when it comes to green innovation. A standard deviation increase in the measure of climate change opportunities leads to, in terms of economic effect, an increase in patents by about 32%. And similar measures with respect to clean tech creation yield similar results. Just as a side note, you also see that a lot of firms that have regulatory exposure have also more green innovation. And that's not particularly strange in our sample. We know, and we show this in the paper, that those firms that have the largest regulatory exposure, mostly because they have large emissions, are also those firms that have the largest opportunities. And as you know, some firms in your region that are very carbon intense actually are also ranking among the firms with the highest level of green innovation. Now, we don't just stop at real outcomes. It's a finance paper. So we also look on top of green job creation and green patents at financial market measures. We show that the measures predict forward-looking risk measures derived from options. For example, we show that firms with higher regulatory risk exposure face larger downside tail risk. So what you can do is you can look at option prices and you infer how relatively expensive it is to insure yourself against a large decline in the stock price, because options are insurance products. And we find that those firms that have a very large exposure to climate regulatory risk have options that are more expensive when they protect you against a large decline in the stock price. In the remaining 4 or 5 minutes, let me talk about the paper's impact, the so what question. We're very glad that our paper had a major impact in academia, but also among practitioners. I already indicated the article is the most cited article in the Journal of Finance over the past 5 years. We're very proud of that. We have now more than 875 Google Scholar citations, and if you know about finance, if you know about accounting, for a paper that was just very recently published, this is a very large number. And in parts, that's because our data are widely used around the world to study finance topics related to climate change. Not just by universities, but also by central banks. And you see here one example for a paper titled Climate Change Exposure and Green Bonds Issuance, where people are using our measure, our updated measure, which we make available for free, and see if our measure of exposure also relates in that context here to green bond issuance. And there are dozens of other papers that look at other outcome variables, including leverage, productivity, and so on. We're also very glad that our paper seems to be useful for practitioners too. So the paper was ranked by the Financial Times in a ranking, Business School Sustainability Research, what is read the most, as the number 4 paper. And it was also cited in the SEC rules regarding mandatory climate risk disclosures. It was cited by the Federal Reserve or covered by UNPRI. Let me conclude and also try to link again back to the ADIA Lab Best Paper award criteria. What we do is we construct and apply new measures of firm-level climate change exposure, thereby contributing to a grand challenge, which is a lack of reliable, transparent, and timely data that allows the measurement of climate change exposure. And we're doing this through the application of data science. The measures offer us, but also other researchers, regulators, and investors, insights that contribute to our understanding of climate change and its mitigation. And let me end by stressing again how important it is for researchers to come up with such measures. We're currently in a situation when you ask investors, where the vast majority of investors rely on a relatively small subset of data providers to measure climate change exposure, for example, using emissions. And it's important for the resilience of our financial system that alternative sources of data are also made available, especially also for academics with limited budgets. On my watch, it's now 29 minutes and a couple of seconds.
Yes.
So thank you very much for the opportunity to present and for considering our work. And me and my co-authors, we look forward to any deep dives and questions about the paper. Thank you.
Thank you, Zacharias. That's perfect on time. So it's my pleasure to open up for questions. So first, of course, to our reviewers, and would you please use the raise the hand icon on your computer so I can call you up. Any questions? Well, let me ask for first question. So is this methodology that you have used, could you apply it by just changing words to some other risks? So for example, to use a current hot topic, exposure to tariffs. So could you do exactly the same and then come up with a different measure for different risks?
So that's a great question. So indeed, there is a big literature in finance and in accounting, and Lawrence van Lent, our co-author, has been instrumental in this, that is applying similar approaches to other topics. For example, political uncertainty. So he has a highly cited paper that looks at political uncertainty, but there is still an innovation in our paper also on the methodology side, because in other contexts, it may be okay to use these pre-identified keywords, but that's, as we have learned, not so suitable in our context. So there's really also a methodological contribution that we have in this paper. But you're absolutely right. The approach can also be applied for other contexts, and Lawrence and others have looked at COVID, for example, where the firms talk about COVID in the earnings calls, and now a very timely topic indeed could be looking at geopolitics, tariffs, and similar. Absolutely.
Okay, any other questions? Please raise your hand.
Well, okay, I will raise hand here.
Okay, go ahead, Alex.
Okay. All right. Okay. Yeah, a very fascinating research. Thank you very much for sharing it with us. Let me ask you two questions. One, to follow what Professor Seven was alluding to. Is it possible to analyze, this earning calls in mass and figure out at any given moment in time what is the most consequential topic for these firms, so to speak? It should be changing over time, right? So I would imagine a few years back, or even last year, perhaps, the climate change was at the top. Right now, obviously, tariffs and things like that. But in general, the environment is changing, and so firms become more concerned with other topics. Can you kind of study this dynamically, so to speak?
That's a great question, Alexander. Thank you very much. Absolutely. So in fact, one of the reasons why we have a lot of citations is because people have started to use that approach and apply it in other contexts. So it's probably a great idea to kind of create, based on this, an indicator that varies over time about the top 5 topics that investors in these earnings calls are concerned about. So that's a great idea. I haven't seen this. Now let me emphasize again that because we see these dynamics in the topics over time, it's so critical to have this keyword searching algorithm, because the way topics are discussed changes over time. And so therefore, you cannot simply identify a set of keywords at the beginning of a sample and then run this over the earnings call transcripts. It's important to have this dynamic feature in the algorithm that is featuring in our analysis and allows the method to learn over time, in our context, climate change, what issues are being discussed. And so you also want to do that, of course, when you look at other topics.
That is very interesting. And, to follow up with that, I appreciate fully that it is impossible to identify the set of keywords ahead of time and so on. But nowadays, there's large language models having greater and greater capabilities of offering short, like extract the main topics of a particular text, so to speak. And I assume that you work with transcripts rather than with speech, right? Because in reality, there is no need to kind of to listen to this clearly. And so, what if you run it first through LLM algorithms to ask it to provide a summary of the call with an emphasis on climate change. Would that be worse or better than your approach? How would it work?
Great question. So in fact, when we wrote the paper, there was no LLM available, ChatGPT available. And in fact, we have a follow-up project among the four of us that we've just recently released. And there we're making use of exactly what you're saying. So the approach that we use here is very suitable if you want to score an entire transcript, because there, at the sentence level, so to speak, any noise that comes in from, maybe the crude approach we have is washing out. But if you want to identify something at the sentence level, this is different. And that's very relevant now for our follow-up paper, because in the follow-up paper, we zero in on the analysts that are asking questions. And so we focus on an individual analyst and an individual question by that analyst. So you have a very short text document. And what we do in this follow-up project is we try to understand whether analysts ask questions that may be motivated by values motives, by pro-social preferences. Because if you think about climate change questions, right, so they could be motivated by financial considerations, but they could also be motivated by pro-social preferences. You want firms to change because you have a preference for firms not affecting climate change negatively, even if that issue is not financially material. And for that follow-up project, we do exactly what you suggested. So we're using an LLM, and intuitively what we do is we look in order to measure whether these text fragments are about values or social preferences. We look at impact funds and their investment statements. So these are funds where we know they care about impact or social preferences. So we basically feed that to the LLM for the LLM to learn how or what kind of words are being used when it's about values, moral, and similar context, and then apply that to the snippets, to the individual sentences that are posed by the analyst. So you're absolutely right, and it would probably be a good idea to apply the approach also now with backward looking again to our paper and see how different it would be.
Okay, I got it.
Just
Thank you very much.
Can I just say one more very short addition? So we tried several approaches using these out-of-the-box models. And the problem is that out-of-the-box model does not always work well. So we basically have to fine-tune lots of them using some specific data for the domain that we're using, and then they start performing. Okay, so certainly there are lots of possibilities, but you also have to have some domain knowledge to fine-tune the model that you want to use for a specific task.
Yeah, I completely agree. Thank you very much, gentlemen. I have no more questions.
So Steve Drew is next. He had patiently waiting for the question.
Yeah, two questions. First, reinsurance and insurance companies have been doing this for decades. And could you expand a little bit on what you're doing that's different, and how much do these insurance and reinsurance companies now use your methods? That's part one. Part two is damages. How do you assess the damages? I heard sometime during your presentation that it depends on a lot of things like newspaper articles, which may be notoriously unreliable either way, in the positive or the negative direction. And so in getting these models, how do you actually quantify this? Because with good data, and how do you validate that data?
And another great question. So you're absolutely right. Insurance companies for years have been compiling data on physical risks of companies. Right? Not so much on transition risks, right? So to what extent firms are at risk because they produce large emissions, and there may be a carbon tax and the like. Now, the limitation is that the data that the insurance companies have is their proprietary business model. They're not sharing the data. They're not making the data publicly available to other researchers. Now, there are data providers like MSCI. MSCI provides a climate value at risk, which is basically building on the different scientifically derived scenarios and then the implications for all kinds of extreme climate scenarios, and then aggregates it up at the firm level. So there are measures that are available by these commercial data providers on the physical climate change exposure of companies, similar to what insurance and reinsurance companies have been doing. Of course, often, you know, not only at the firm level, but more granularly. Now, the big drawback of all of this is that only through the scenarios that's forward-looking. And in our case, right, if you believe a firm is very highly exposed to a certain scenario and that scenario poses lots of risk, it should feature in the earnings calls. Because if that scenario is financially material, analysts or management should talk about it. So we see that more as complementary measures, right? And you know, certainly we also show that there are correlations, and we have that in the paper between our measures and those that are provided by these commercial data providers. But the correlations are not 99% or similar. There is additional information, forward-looking information in our measures. And then finally, to your other question, you're absolutely right. And we show this also. If over time in the newspapers, as you indicated, there's more discussion about climate topics, and there's a time varying index for that, then we also see that climate topics feature more prominently in earnings calls.
Can you, just a quick follow-up, one of the ways of validating, a good way, is to look back at a recent decade or 2 decades and use that data to predict what happens in the following decades where you actually have ground truth, you actually know what happened. And then to see, using your models, how well you predicted what would happen, turning the clock backward.
Absolutely. So we have done it to some degree, not in this paper, but in a related piece where we have looked at litigation. And so we have started to measure, and that goes back to an earlier question, right? You know, how can you adjust the model, whether there's talk about climate-related litigation in the earnings calls. And so there we have a measure, and you're absolutely right now that there are measures of actual litigation cases coming up, because this is very recent. Only you know, a few weeks ago, there was a paper published in Nature Climate Change with the first database on climate-related litigation. We could do exactly that, link that specific climate risk topic litigation to actual litigation cases and see how well it performs. Right. So also here, that wasn't available, you know, the couple of months back when we wrote the paper, but it would be available now, and that's definitely the good idea to do.
Yeah, but it doesn't have to be litigation only. It could be things like, you know, crop failures. Farmers will actually maybe draw on their insurance or the country's, you know, aid, things like that. So there are many, many measures of what might happen that could indicate costs that give you perhaps more reliable data. When someone files an insurance claim and then they settle the insurance claim, somehow, you know, there's a compromise made, and then it gives you perhaps an estimate of real damages.
Right. So for us, of course, you know, the task would be to aggregate all of this up to the firm level, because our observations are firms, and certainly there are also insurance companies and reinsurance companies in the sample. But you're right, if one would be able to trace back all of these events to individual firms, then this is definitely possible. But let me say, and you know, I also work on biodiversity finance topics, that the big data challenge there is location data. Right? So we essentially have very limited, especially on a global scale, data on where firms have their physical assets located. Right? So that very much limits the ability to link locations to physical weather events, climate change events, and then aggregate this up. Right? And so that's on the biodiversity side even more important, right? Where you want to measure dependencies and impacts and so on. But it's certainly also a challenge here, especially at a
Thank-
global scale. Yeah.
all right. Thank you.
Very good. Thank you. Any other questions? Please raise your hand or use your raising hand icon. I don't see any more questions. So the co-authors, do they want to offer some other insights or additional points of view? If not, then I think we can conclude the evening or the afternoon and thank Professor Sautner and his team for their presentation and their paper. Thank you. And
Thank you
thanks
very
to all
much.
our reviewers who have been diligently following for 5 Wednesdays the presentations. Thank you.
Thank you.
Thank you so much.
Thanks. Bye-bye.
Thank you.
Bye-bye.
Take care. Bye.